So today we are gonna be solving tons of questions related to our very first topic of A levels chemistry, AS level chemistry, that is atomic structure. So let's get started with the past paper questions. They're really tricky, because when you jump from O or IGCSE, O levels or IGCSE to A levels, it's difficult to cope up, but we're gonna, do all types of questions and I'm gonna explain to you all tactics, tricks, how to figure out the configurations from the periodic table and everything. So let's get started. In which species is there a lone pair of electrons? So what's a lone pair? A lone pair is basically two electrons that are unbonded. Okay, first let's figure out for CH3. The structure for CH3 is going to be something like there's going to be a carbon atom and there are going to be three hydrogen atoms. And we're gonna have three shared pairs of electrons like these. But we know that our carbon, it basically has a valency of 4. It means it has 4 electrons in its outer shell. And if 3 electrons are making bonds, then of course there's gonna be 1 electron that's not gonna make a bond, and that's gonna be over here. So we have 1 unbonded electron, but we cannot consider it as a lone pair. A lone pair means it should be a pair of electrons that are unbonded, but over here we have only 1 electron. Let's check out for CH3 plus. Obviously we know if CH3 does not have, CH3 plus means it lost this electron. So obviously when it loses this 1 electron as well, it's obviously going to have no lone pair. CH3 negative. CH3 negative means that this is the structure, and now in this structure, this is a CH3 structure. We add 1 electron from here. And when we add 1 electron in this CH3 structure, let's add 1 electron. This electron, it's gained this electron, it's gonna have 1 lone pair. This one right here is a lone pair. So the correct answer is gonna be option number C. Let's check out for option D as well, which says CH4. CH4 is gonna have all electrons bonded. This is gonna be a carbon atom, and we have 4 hydrogen atoms. 1 hydrogen, 2 hydrogen, 3 hydrogen, and 4 hydrogens. And all hydrogens are gonna make a single bond with the carbon atom. We're gonna have no lone pair of electrons. So here we go with the CH4 structure, which is no lone pairs at all. Question 12 says, this question says, which atom contains 4 times as many neutrons as a lithium 7,3 atom? Okay, first we have to figure out the number of neutrons in a lithium 3,7 atom. Okay, that simply we just subtract 7 minus 3, which gives us 4. So we have 4 protons. No, not protons. We have 3 protons. We have 4 neutrons in a lithium atom. And now we have to figure out a particle which has 4 times the neutrons in a lithium atom. And in a lithium atom we have 4. So 4 times 4. So now we have to multiply 4 with 4, and this gives us 16. So we're looking for 16 neutrons. Do we have a sulfur here? Because sulfur is 16 neutrons. No, we don't. Over here we have 20 neutrons. Over here we have 12 neutrons. Over here we have 16 neutrons. And over here we have 2 and 1. 12 neutrons. So it's going to be option number C. I guess this was easy enough. Let's move on to this question. Which sample contains the most iodine? Okay, I guess this is related to a bit of moles, because we have to work out a little bit with moles. 1 gram of Ci2O, that you have to know the masses and everything, so we're not going to do this. Let's move on to this question related to ionization energies, and this is a really interesting question. Equations involving 4 enthalpy changes are shown below. Okay, which equation represents the second ionization energy of sodium? You need to realize one thing, that when we have to work out the second ionization energy of sodium, we are going to form a 2 plus ion on sodium. And you might think, after looking at this equation, that delta HX is the second ionization energy of sodium, but that's incorrect. Why? Because over here you're taking out 2 electrons of a sodium atom. That's incorrect. You have to take out the 2 electrons from a sodium 1 plus ion. You have to just take out 1 electron out of a sodium 1 plus ion, and that's your enthalpy change or the ionization energy. Why not these two? Because these two are solid, and ionization energy is when you take 1 mole of atom out of a gaseous atom. 1 mole of gaseous atoms, 1 mole of electrons from gaseous atom, 1 mole of gaseous atom. So solids we cannot take. We need to take gases, and this is a gas. But the problem with this is that it's not the second ionization energy. We're taking out of a sodium atom. So first we have to do this. We have to take out 1 electron from a sodium atom and form a sodium ion. That's going to be a +1, and then from +1 we have to go to 2+. So that's going to be X is the total energy, like the total energy that you get out of a sodium atom. So the value is going to of the ionization energy of the second ionization energy should be a little less than X. Why less than X? Because X is taking out of a atom. It's taking out of an atom 2 electrons directly. We need to take out of a 1+ ion. Only 1 electron we need to take out. So it has to be X, and we subtract from it the first ionization energy because we don't need the first one. We just need the second one. And this is the first ionization energy, which is we take out from a sodium atom 1 electron out. That's the first. We subtract the first ionization energy from the second one, because this is telling us not the second ionization energy. This is a combined value of the first and the second, because we're forming an ion directly from a atom. So I hope you get it. So it's going to be X minus W, which makes option number C the correct one. Moving on to this question, which says a student reacts 1 mole of copper. I guess we're dealing with moles again, and that's not what we're doing. Okay, that's a moles question. Which element has the second smallest atomic radius in its group and the second highest electrical conductivity in its period? Okay, so I guess it has to be second highest electrical conductivity in its period and second smallest atomic radius. It has to be magnesium. Why? Because if you look at the periodic table, you look at magnesium over here. This is your magnesium. And a property of magnesium is that magnesium, what it's going to do is, it has the second highest ionization energy in its period, in its group. Why? Because first highest ionization energy is going to be of beryllium, and the second highest is going to be of magnesium. So, and in the period, as you know, electrical conductivity increases across a period till aluminum. After aluminum, it's going to decrease. Silicon, phosphorus, they're going to form covalent bonds. That's not going to conduct electricity. So first sodium, then the second best electrical conductivity first is going to be aluminum, best electrical conductor. Why? Because in the aluminum structure, there are going to be 3 valence electrons that are going to get out of the atom and form the metallic bond. Whereas in magnesium structure, there are going to be 2 valence electrons. In sodium, 1. So best is going to be aluminum, the best conductor, then magnesium, and then sodium. So it's going to be magnesium. Second highest ionization energy and second best conductivity. So obviously magnesium. Which atom is exactly 3 unpaired electrons in ground state? Unpaired electrons are electrons that are alone. And just by looking at it, I know it's phosphorus. Why I know it's phosphorus? Because look, it's easy. You just need to know the periodic table, and you're going to solve it in a bit. How many unpaired electrons aluminum has? 1 unpaired. How many carbon has? Carbon is going to have 2 unpaired. Yeah, it's going to be 2. And for chromium is going to have 6 unpaired. They're going to be 6 unpaired, and in phosphorus, they're going to be 3 unpaired. How do I know this? Without even looking. How do I know it? This is the p block. This right here, this block. This is the barrier. These are not p block. After this, boron, aluminum, gallium, indium, they're all p block elements. And now aluminum is going to be 3p1. The last subshell of aluminum is going to be 3p1. How do I know it? Because it's in third period. First period, second period, third period. It's in third pair, so it's going to be 3. It's in P block. This is the P block, so it's going to be P. And 1, why 1? Because it is the first element in its period in the P block. This is the S block, this sodium magnesium. This aluminum is the first element in its period in the P block. This is the P block, aluminum. Silicon is going to be 3p2, third period, and the second element in its period in the P block. Phosphorus is going to be 3p3. Sulfur is going to be 3p4. Oh, sorry. Carbon is going to be 2p2. So carbon is going to have 2. Okay, good. I wrote 2. Carbon is going to be 2p2. And nitrogen is going to be 2p3. Arsenic is going to be, first we need to figure out the period, 1, 2, 3, fourth period. In the fourth period, it's in P block, 4p1, 4p2, 4p3. So arsenic is going to be 4p3. That's how you figure out the configurations. So we know that a phosphorus atom is going to have 3 unpaired electrons in its 3p orbital. It's going to be something like this, and you're going to have 3 electrons in it. 1 electron, 2 electron, and 3 electrons. Done and dusted. Okay, this is an interesting question, a very interesting question. Element J and L are both in group 15. Okay, we know if they're in group 15, how many electrons should be in the valence shell? There should be 5 electrons. This 5 looks like a 6, but it is a 5. Okay, J and L each form a gaseous covalent hydride in which the oxidation number is -3. It should be -3. Why? Because, for example, you take any atom like nitrogen is in group 15 and you form NH3. Over here, nitrogen is a -3 and hydrogen is a +3. Why? Because nitrogen is more electronegative. This is nitrogen. These 3 are your hydrogens, and what's happening is this shared pair of electrons, it's gonna be pulled towards nitrogen because nitrogen is more electronegative. So in NH3 like this, it's gonna be something like this. This is gonna be a shape. Hydrogen is gonna be slightly positive, partial positive, and nitrogen is gonna be partial negative. So there's gonna be a 3 negative charge in nitrogen. Okay. In the liquefied form of these hydrides, significant hydrogen bonding occurs only in the hydride of L. Okay, that's a good point which we're given. That only in the hydride of L, there's going to be a significant hydrogen bonding. Hydrogen bonding occurs if you have an NH bond. Why does hydrogen bonding occur? Firstly, you should have a great electronegativity difference. That's going to make it polar. And second, hydrogen bonding, when it's polar, then this hydrogen, which is going to be partially positive, is going to be attracted to a lone pair of NH like this. There's going to be a lone pair, 3 electrons bonded to are going to be a lone pair of nitrogen. On another NH bond, this hydrogen is going to be attracted to this lone pair. That's what hydrogen bonding is. So in NH, in OH there's a hydrogen bonding, and in FH there's a hydrogen bonding. So that means that L is definitely going to be nitrogen. Which row about J and L could be correct? Outer shell electronic configuration. Obviously it cannot be P5. It has to be S2 and P3. Why it has to be S2 and P3? Because in the outer shell, there is not only going to be a P subshell, there are going to be S subshell as well. So you cannot only consider P and fill all the electrons in P. Indeed, S is going to be filled before P. So this is going to be the correct, and then I don't care what the other element is, it's B. This was easy. This question refers to an isolated gaseous atom in ground state in which atom are all electrons paired. All electrons paired. You just look at the periodic table and you know it's barium. How do I know it's barium? Easy peasy, because bromine, it's gonna be 3p 1 2 3 4 5. The last shell, not 3p, it might be 4p, but it's gonna be p5, the last subshell. For sulfur, it's gonna be p4. For silicon, it's gonna be P2. How do I know these last shells? Because last subshells, because I know the periodic table. Look, sulfur is here. So it's gonna be, it's in period 3, 1, 2, 3, the third period. And now if I move across the third period in the P block, 3p1, 3p2, 3p3, 3p4. So sulfur is gonna be 3p4. And what was the other element? It was bromine. Bromine is in fourth period. 4p1 gallium, 4p2 germanium, 4p3 arsenic, 4p5 selenium, 4p1, 2, 3, 4p4 selenium, 4p5 bromine. And the next was silicon. Silicon is this. It's in third period, 3p1, 3p2. And they're not filled subshells. The filled subshell is going to be of barium. Where is barium? This is barium. This is the S subshell. S block. This lithium, beryllium, these are all S block. So it's going to be in the sixth period. Barium is in the sixth period, and then it has 6s2. In this block, 6s1, cesium is 6s1, and barium is 6s2. You can check. This is all the information about barium. The energy levels and everything, it's going to be 6s2. So filled electrons are paired in the 6s2 subshell, because in the 6s2 it's going to be a big circle. Firstly, it's S subshell, and there are going to be 2 paired electrons in it. So which atom has the same number of electrons at a hydroxide ion? Okay, a hydroxide ion, oxygen, how many electrons it has? It has 8 electrons. Hydrogen has 1 electron, and you've gained 1, so plus 1. 8 plus 1 plus 1, that makes 10 electrons, and I guess only neon has 10 electrons. So that's it for today's video. I hope you liked it. Do consider subscribing to my channel. That's gonna mean a lot.